So again, welcome back future achievers. Okay, and this session we are going to discuss equivalent moles and equivalent mass. Okay, what is equivalent moles? What is equivalent mole and mass? Okay, let's go and discuss this. Okay. Okay, first of all we need to discuss what is equivalent mass. Okay, to find equivalent mass you have to divide the molar mass. It is as same as molar mass. Okay, the concept for molar mass is similar as equivalent mass. Okay, the concept of equivalent moles is as same as moles. The concept of molarity is same as normality. Okay, got it? One side is normal moles, normal mass. Okay, another side is equivalent moles, equivalent mass. Okay, got it? That's it. Okay. Now the definition says that the equivalent mass is molar mass divided by n factor. Here n factor is the number. Okay, you need to determine what is this number. Okay, and in different cases of compounds we have these different numbers. Okay, let's see. So whether it's acid, bases, salts, redox reactions. Okay, so we have different ways to find what is the value of n, and then we divide the molar mass with that value to get what is the equivalent mass of that substance. Okay, now okay, let's change the color first, white. So equivalent mass is molar mass divided by n factor. Now to determine n factor we have different what you call it, techniques. For acids, can you name me some acids? Sir, one acid is sir HCl. Okay, another acid sir H2SO4. Any other acid is there? No. There is any other acids. Okay, so it is like number of replaceable H plus ions. Okay, always remember the not the number of hydrogen ions, it should be number of replaceable hydrogen ions. Okay, so suppose H2SO4 has 2 hydrogen atoms. Okay, first of all takes the easy one, HCl. So HCl is going to dissolve, it is going to give one H positive ion, right? So how many number of replaceable H positive ions? 1. But if H2SO4 only gives out, okay, 1 H positive ion. If it gives out 1 H positive ion during the dissolution, then the value of n is 1. But if it gives out 2, okay, if it gives out 2 hydrogen ions, okay, gives out 2 hydrogen ions, then in that case the value of n is 2. Okay, it doesn't mean number of hydrogen atoms in that compound. It means how many atoms are going to dissolute, okay, while they are in the solution. Okay, so for an example, if C6H12O6 is there, okay, then what is the value of n in there? No, first of all, if it's an acid, okay, how many atoms it is going to leave? Although this is not an acid, but there are 12 hydrogen in it, but it doesn't mean 12 hydrogen atoms are going to dissociate. We need to find out how many number of hydrogen atoms, replaceable hydrogen atoms are going to displace. Okay, and this same logic goes for what you call it, I'll clean just, okay, the same logic goes for bases also. We have the base, can you tell me? KOH, we have the base, call it NaOH. Okay, so how many number of replaceable, I am stressing my particular thing on this particular word, replaceable. It should be replaceable, it should not just be present there, it can be replaceable during a neutralization or any solution reaction. Okay, so KOH, NaOH, they will give 1 OH negative plus K positive, same it will give how many, 1 OH negative and Na positive. Okay, now how many number of replaceable OH negative ions? 1, so the value of N is 1 for these bases. Got it? Now when it comes to salt, okay, for salt it is a total positive or the negative charge which is getting balanced. For an example, tell me one salt, sir, NaCl. So it is found with one Na positive and one Cl negative. So what is the amount, magnitude of single either positive charge or either negative charge? You can calculate any of them, but pick only one of them. Okay, either single positive charge or single negative charge. Okay, so it means what? It means it is 1, magnitude is 1. So that is for salts the value of n is, this is how it is calculated. Okay, can we pick any other salt? Okay, to pick any other salt, for an example, just okay, let's just take it K2CO3. Okay, now K2CO3, how do you do it? Tell me. K2 is 2 times of K positive and plus CO3 2 negative. What is the amount of charge that is getting balanced? Sir, it is 1 positive. No, it is multiplied by 2. So, 2 positive and 2 negative. So, what is the value of 2? Oh, sorry, what is the value of N? 2 for salts. Okay. Okay, and okay, for redox reaction, the value of N is how many electrons is gained and how many electrons are lost per molecule. Okay, so if we have a molecule, it is losing 2 electrons. Okay, one molecule is losing 2 electrons, then the value of N is 2. If 10 compounds, 10 molecules are losing 30 elements, okay, 30 electrons. So suppose 10 molecule is there which is losing 30 electrons, okay, then it means what is the value of N? 30 divided by 10. What is per molecule? That is 3. Value of N is 3. Got it? This is the way, this is the definition of equivalent mass, molar mass divided by some number. That number for acid is, this is how you find it. For base, this is how you found it. And for salt, this is how you find it. For redox reaction, this is how you find it. Got it? Now let's go on to the next definition. Okay. So how do you find out moles? Sir, we find out moles by dividing given mass with the molar mass. Same way, for equivalent moles, we have given mass divided by equivalent mass. That's it. Given mass by molar mass is the normal moles. Given mass by what you call it? Equivalent moles. Got it? Now you can also find the normality. Normality is equal to equivalent number of into multi. Oh, it should be division. Okay, it should be division. Equivalent moles per unit volume. Same way, what is molarity? Molarity is moles per unit volume. Normality is what? Equivalent moles per unit volume. Okay, so the equivalent thing is getting involved. I hope now you understand it. It's very simple. Moles is what? Given mass by equivalent mass. That's it. Okay. Okay, so first of all, why we are even studying this thing? Okay, first of all, it helps in the stoichiometric balancing the equation. Okay, and in case of the redox reaction, these things are used. And titrations, acid base neutralization titration. Okay, you will hear this. I hope you have heard of that experiment, acid base titration. Okay, that purple color experiment. Okay, so you are just putting the dots and the purple color appears. In that case also we are using this particular concept of equivalent mass and equivalent moles. Okay, by the way, this is just theoretical thing. Okay, let's do some questions. Okay, so based upon the definition, can you just try to do this question? I will get out of frame, pause the video, try to do it. I hope you have done the question. Okay, so calculate the equivalent mass of H2SO4. To calculate equivalent mass, divide molar mass by N. Got it? So equivalent mass is equal to molar mass divided by N. Now it is asking for the complete dissociation, partial dissociation to HSO4 negative. It means when this particular compound dissociates to this compound, it means it is only leaving behind one H positive ion. So when in this case I have told you only one H positive ion is replaceable. So in this case the value of N is what? 1. Got it? But during the complete dissociation, both of these two hydrogen ions, atoms are going to be released. So in that case, replaceable hydrogen ions are what? How many number? 2. So now for A, it is N's value is 2. For B, the N value is 1. H2SO4 has a mass of 98 gram. Okay, divided by N. Okay, so here equivalent mass is what? Given molar mass divided by N. Molar mass divided by N. Our answer is 49. Here what? 98. So here 49 equivalent mass per mole. Here 98 equivalent mass per mole. Got it? This is our answer. Let's go on to the next question. Okay. Okay. So how many equivalent moles are there which are present in 49 gram of H2SO4? 49 gram of H2SO4. But always remember, for H2SO4 there are two cases: complete dissociation, partial dissociation. Okay, for complete dissociation 49 gram per mole. Okay, for partial dissociation 98 gram per mole. Okay, the equivalent mass I am talking about. If it dissociates completely, so now in the previous question, if you rewind this video back, you will see that during the complete dissociation, value of N was 2. So the equivalent mass was 49 gram. Got it? okay, that is the equivalent mass. Now the given mass is 49 gram. How many equivalent moles? We have to find out equivalent number of moles. So equivalent number of moles is equal to given mass upon equivalent mass, and that is equal to 1. That's it. Okay. I hope I am understandable with these questions. Okay. Let's do another question. Okay. Try to attempt the question before I get it. Okay. So that you just practice yourself. In a redox reaction, 10 gram of Fe2 positive. Okay. This is the molar mass. Okay, and the N factor is also given, is oxidized. Calculate the equivalent moles. Okay, let's do this. In a redox reaction, 10 gram of Fe2 positive is there. So Fe2 positive. Okay, Fe2 positive is there. Now, whose molar mass is 56 gram per mole. So molar mass is 56 gram per mole. Okay, and the value of N is also given. When you divide it with the value of N, you will get what? Equivalent mass. The equivalent mass is what? Again 56 is the equivalent mass. So is oxidized, calculate the equivalent moles. We just need to calculate equivalent moles. So this is the equivalent mass, given mass. So equivalent mass is what? Sorry, equivalent moles is what? Sorry, equivalent moles is what? Given mass upon equivalent mass, that is 56. So this is our answer, 10 by 56. I hope this question is understandable. Okay, it's nothing difficult. Okay. Okay, so this is the last slide. Okay, let's just quickly revise what we have done. Okay, what does equivalent mass tells us? Equivalent mass tells us the chemical reactivity. Okay, more the equivalent mass of a substance, more is its chemical reactivity. Okay, now equivalent moles simplify stoichiometry. Obviously, we are able to understand the equation far better when we know equivalent moles. So, and the last is key formulas are this one. That's it. Equivalent mass is equal to molar mass by divided N factor, and equivalent moles is equal to given mass upon equivalent mass. I hope now you are able to understand this. Okay, and that is it for today. Take care. See ya. Bye bye. Have a nice day. We'll meet in some other lecture with some other topic. Till then, bye bye.